So we've thought through what's going on when you have a relative motion between your observer and your source for sound, and that has to do with moving with respect to the medium. Now, you're going to notice that the equation looks quite a bit different from light. First, we're talking about wavelength, not frequency. Second, there's a square root here. Again, this is coming from special relativity. This is not coming from the same effect. So what's strange is that it gives you a similar phenomena, but the underlying physics is vastly different. So if you'd like to understand where this actually comes from a physics point of view, you need to take modern physics. Special relativity takes a couple of weeks to cover, and we're not going to do that in intro. So notice that again, we have Vs, which is still going to be the speed of the source. C is the speed of the wave because we're talking about light, which is an electromagnetic wave. And notice that again, we are talking explicitly about wavelength, but you could convert from wavelength to frequency if you wanted, right? That's still something you can do. Now, we have a receding source, so the source is moving away from you, and we have an approaching source, the source is moving towards you. But now notice that we're going to see something different happen because we have wavelength rather than frequency. So in the case of a receding source, this is going to look longer, the wavelength. And in the case of an approaching source, this is going to look shorter. And remember that c, the speed of light, is a pretty big number, right? This is 3 times 10 to the 8 meters per second. So if you're just talking about a car speed that's like a couple of meters per second, you don't really see an effect. So for this to be notable, you really have to be traveling very, very fast. So when would we actually observe this phenomena? Very rarely do we observe it on Earth. We can see this in particle physics experiments, but the big place where this comes up is actually in astrophysics. And you might, if you've heard anything about astronomy, you might have heard about redshifted and blue-shifted objects. So redshifted means that the wavelength is longer. Red light has a longer wavelength than blue light. Blue light means the wavelength is shorter. And again, approaching means made shorter. Receding means made longer. So this is your red, and this is your blue. So if you have a source that you know should appear yellow, which is roughly in the middle of the spectrum, and when you see it, it actually looks red, that means it's traveling away from you. If your yellow source looks blue, that means it's actually traveling towards you. Now notice that you might have a source that you know is red and it looks yellow. That's still blue shifted. So again, it isn't the absolute color, it's more the direction on the electromagnetic spectrum. So why does this matter? Well, when we look out at stuff in space, we can actually measure these different wavelengths. And for many objects, we know what these wavelengths should be. So for instance, we know if there's hydrogen in our object, we know that there are certain wavelengths that hydrogen should produce. And if we see those things shifted a little bit, we can measure the speed of the object. So this blur here, I don't know why the book chose this picture in particular, but this blur is of a quasar that is actually moving away from us at 0.9 c. So this is very, 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 very redshifted because it's moving very, very, very fast away from us. So it's really impressive that it's moving this fast. And where this is important, you've possibly heard about it, is we know that the universe is expanding. And what that means is that every single point, or every single star, every single galaxy out there, seems to be traveling away from us. And how that was discovered was that everything is redshifted. Everything is moving away from us. Things aren't moving towards us. Things are moving away. So that was one of Hubble's discoveries. Things are redshifted. That means the galaxy is expanding. So again, this is coming from relativity, so we're not really going to go into detail, but we can still talk about the changes in wavelength due to this Doppler effect. And using these equations, note again that you might get, for instance, red light is quote-unquote blue shifted into green light because its wavelength has gotten shorter.